Cool. Thanks, everyone. This is Old Solutions to New Testing Problems, and I'm Josh Justice. I work at Big Nerd Ranch, so we're a consultancy. We do web development and mobile development and some React Native development, kind of cross them over. We also teach week-long boot camps on all of those technologies, and we publish Big Nerd guides on them as well. So teaching, building, we love to do kind of all that stuff together. So talking about these old solutions to new testing problems, I feel like in the last couple of years, JavaScript test tooling has really improved a lot. For example, we have folks here from Jest, from Cypress, from Percy. These are all really amazing tools. There's a bunch of other amazing tools as well. And I feel like we're really at a point where whatever you want to test in your JavaScript application, like there's a tool that'll help you do it. Like not being able to test is no longer the problem. What I think the problem and the challenge is test maintainability. So as our applications grow bigger and bigger and get older and older over time, we evolve them, the test suites tend to get harder to maintain. They can be expensive. A lot of tests, the more you change production code, the more and more tests will fail sometimes. So it can just get harder and slower to build and kind of improve your application. And I think this is something that tools can't fully solve for us. I think there's an inherent ambiguity to testing. There's judgment calls you have to make to decide how you're going to test, how you're going to write your tests. And so I think just knowledge is involved in addition to all these tools. So a question that we have, and I think a challenge that we have, is how can we as JavaScript developers learn to write more maintainable tests? And I can tell you what the answer was for me: Ruby. Anyone know any Ruby developers that are obsessed with testing? Is Justin Searles here this year? Anyone know? So I learned good testing practices working in Ruby, and so that worked fine for me. But then all of a sudden it didn't work quite so fine. I ended up on a big JavaScript front-end project for a really large tech enterprise, and they had an established testing approach that I felt like could maybe do for some changes. So I tried to kind of propose some changes, but I wasn't really able to convince them. What can I do to kind of make a case that me as just one individual developer that they should kind of rethink their testing approach? So I could say, well, actually in Ruby we write tests like this. I don't think that would be very effective. Like nobody cares how I write my tests in Ruby. So how can I share what I know in a helpful way for others? And how can we as JavaScript developers learn testing principles from outside the language ecosystem that we work in day to day? I think something that can help with that is the idea of software patterns in general, and specifically test patterns. So there's a book called xUnit Test Patterns by a guy named Gerard Mazzaros. It was written in 2007, and it describes patterns for writing automated tests in a cross-platform way. The patterns are language-agnostic. They're cross-platform. The examples are actually all in Java, but I found that the test patterns that I found really useful in the Ruby world, most of them were reflected in the book. And so that gave me confidence that they would be likely to apply in the JavaScript world as well. So we're going to look at 5 patterns from the book here today. They're ones that I've found most frequently to be helpful in the JavaScript world. 5 kind of test problems, like problem patterns in the code that I see, and we'll look at those, examples of those in JavaScript code. We'll give those problems a name, and we'll give the solutions a name as well, coming out of the book. And we'll see examples of the solutions in the JavaScript code as well. Depending on kind of your testing experience level, I think there's a few different kinds of takeaway you might have. If you're very new to testing, or even somewhat experienced in testing, these testing approaches might be new to you. So you might not know that the thing that we're saying is a problem is actually a problem and could burn you eventually. You might not know what to do about it, so the solution might be new to you. Maybe you do know those things, but you're not really able to articulate it very well to others. Like, well, how do I describe, I don't know, this is just the way we did these tests. I'm not sure why it's better. So maybe you can get an explanation that will help you in conversations with others. And even if you can explain it well, it could be that the shared language of patterns from this book gives you kind of more leverage in making your case. It's not just you anymore. It's now like this history from the testing world, and this is a general concept that people have seen in different languages. So hopefully one of these takeaways will apply to you kind of wherever your experience level is. I want to talk about a phrase that's used in the book. I said problem patterns a minute ago, but code smells is the phrase the book uses. And this term can be kind of offensive, honestly. So I'm going to use a bit of a different phrase. I'm going to use the phrase warning signs. Because part of the point is, despite the kind of harsh soundingness of the term code smells, it was always meant to be a judgment call thing. A code smell doesn't mean that something is definitely wrong. It means that something is likely wrong. So you should take a look and make a decision for yourself if there's actually a problem in your case. And if you are working in front-end development, component-based frameworks, it's a fairly different programming model. So maybe not all of the approaches that worked in the past will work there. So I just want you to definitely feel the freedom to make the judgment calls and to make the assessments based on your context, what is or is not a problem, what solutions will actually make things better. So with that said, let's jump into the first of our patterns on testing. So we have a code snippet here. For several of our examples, we're going to be looking at a real simple function to format an address. So you can see here that we're importing some address data from a sample data file. This example is in Jest, but of course Mocha is very, very similar. Hopefully that y'all as JavaScript developers can follow along with this. So we get multiple addresses from this file, and in our test here, we're looping through them. We're going to get one address at a time. And so we have a conditional here. So some addresses are going to have a street to line, and if so, we're going to format our expected result in a certain way. Other addresses might not have 2 lines in the street address, so we're going to format them in a different way because we don't want the blank line in the middle. It should just kind of compress down. So whichever of those expected results that we wanted, we're going to do our assertion to kind of make sure that it matches up. And our loop is going to continue, and if it finds an address that it doesn't work, it's going to fail on it, but otherwise it'll make it through all of our addresses and make sure that no matter how much test data we have there, that everything's covered. So it works, but I think there are some problems. And as your app grows and as time passes, you can kind of find more problems here. The test can be hard to understand. So if we're used to seeing conditionals and loops in our code, we're developers, but in tests, you really want your test to be as obvious and straightforward as possible. And having to kind of walk through these loops, this logic in your test, it can make it harder to understand. The tests might have a bug once they're not trivial, and you don't test your tests. So that'd be a really unfortunate thing if your tests have a bug and are not working properly. And this one is kind of maybe my biggest concern out of them all. If the test data changes, not all the cases might be executed. So right now we have addresses that have 1 line and addresses that have 2 lines. But maybe that file is an export from a development server. Maybe we overwrite it. Maybe it just so happens that there's no addresses with 2 lines anymore. Now we don't know that that branch is not executed. We don't know that our code is not covered by tests. So this problem is referred to as the flexible test, that's the warning sign, flexible test. And here's how Gerard defines that. He says, a flexible test is using conditional logic to reuse a single test to verify several different cases. And so this is positive words. This all sounds good, but we've just seen some of the problems that this can cause over time. So the solution would be to make simple tests, to split the test into simple cases, controlling for specific situations. We could have one test case that says it formats an address with 2 lines correctly. And so we just pull out the addresses record at line 0, and then we have a single expected result that's always set the same way, because this is a simple test, and then we just check it. We have a separate test case to format an address with 1 line correctly. And so we pull out a different address at a different index, at index 1, and then we have the different expected result, and we're good. So in this case, we have 2 test cases that are always going to run. And so if the address at index 1 changes, if it's no longer is a 1-line address, this test is going to fail. So if both those 2 individual test cases pass, we know that we have the 1-line case and the 2-line case covered, and we can be sure even if the test data changes. So to summarize this, the warning sign is that we had a flexible test, and the solution was to make more simpler tests, split it out into simpler ones. So let's go on to pattern number 2. We're going to continue on with this example, and this is actually starting right where we were before. We've got our test here that pulls out the address at index 1 and looks to format an address with 1 line correctly. You may have been thinking this already in your head as you were assessing this. There's still a lot of questions we have here. So what is at addresses at index 1? What is the contents of it? What does it mean to only have 1 line? Does that mean there's no street2 property? Is it OK if it's undefined or null or an empty string? Is there some kind of config boolean somewhere in the object that says whether it's a 2-line address or not? We don't really know any of this because we don't see the data in front of us. At least in this case, we have a test case with a good name. I don't know if any of y'all have ever seen test cases with unhelpful names before. But if this just said it format address, we would not know what exactly was being tested. If you had several test cases that all said it format address, like I've seen in some kind of code bases, what is the intent? What is going on here? So the problem here is that we can't see the data relevant to what's being tested. We have to look in another file to see what's going on. This makes the test harder to understand. We have to do research to understand our test instead of being able to see it obviously at a glance. So this increased test maintenance costs because if you want to read the test to see what's going on, if the test starts failing and you need to make a change, this is more effort now to understand to know the right change to make to fix it. So it's easier for bugs to sneak through in that situation. If it's a higher barrier to really understand the test, you're less likely to go through, and maybe a bug will kind of crop up. Finally, the test is now coupled to the shared test data in another place. So if that test data breaks, like as I said before, if it's an export from a dev server and you overwrite the whole test data file, the test could break, or worse, it could give a false positive, where the test is green even though it's not actually covering what you hope it's covering. So the warning sign here is what's called mystery guessed. And this is the test reader is not able to see the cause and effect between fixture and verification logic because part of it is done outside the test method. Let's look at this word fixture and define it, because this is going to come up in a few of our different examples here. So a fixture is everything we need in place to exercise the production code, the preconditions of the test. If you're using object-oriented code, you're probably instantiating some objects. In our case, because we have a stateless function, it's just setting up the initial test data that we're going to be passing in, so setting up those object literals. So fixture is what you need in place, the preconditions of the test. Now, a shared fixture is when you reuse the same fixture for several or many tests. So we're going to revisit shared fixture a few different times during this talk. There's a number of downsides with shared fixtures. In this case, what we're seeing is when you reuse that fixture, it's usually set up somewhere distant, and that leads to a mystery guess situation where you can't easily see what's going on in the test. Another approach to fixtures is to use a fresh fixture. This is when each test constructs its own brand new test fixture for its own private use. So we're going to see that in just a second. But going back to the definition of mystery guessed again, the test reader is not able to see the cause and effect between fixture, the original setup data, and verification logic, the output, because part of it is done outside the test method. There's data there, and you don't know what it is. And you really don't want your tests to be mysterious. You want your tests to be abundantly obvious so that anybody looking at them can tell in an instant what's going on. The solution is to set up the data closer to the test, and there's a few different possible approaches we can take using fresh fixtures. So one is called inline setup. Each test method creates its own fresh fixture by building exactly the test fixture it requires. And that's pretty straightforward in this case. We can just put the data right there in the test. So this is certainly the least mysterious, because you can see exactly what the data is that's being passed in. But you could run into a situation where there's a lot of data that's needed, and so that could kind of clutter up your tests. So we can see another approach you can take. Second approach is called delegated setup. Yes, that's right, delegates. So delegated setup is where each test method creates its own fresh fixture by calling creation methods from within the test methods, or creation functions. Let's see an example of a creation function to set up test data. So here we have a function called createAddress. We pass in an options object, and there's just one option, has street 2. So you can set it to true or false to indicate whether you want an address that has a straight line 2. Inside of the function, we set up a new address. It's a new object we create from scratch, just with the minimal data needed for an address. We don't really need the data to vary, so we just kind of put in some hard-coded data. And then if that has street 2 flag is set, then we assign a street 2 property as well. Either way, we just return the address that's been requested. So this is a function that will create the test data we need for either of those two different cases. And you add more conditions as you need more possibilities. Using it is very straightforward. You just call createAddress at the top of your test. You specify has street false or true as you want it. Then you've got your address to run the test off of. And the test for the 2-line case is very obvious. Like you createAddress with has street set to true. So the test is very short. We can see that we're creating an address, and we can see that it does or doesn't have a street 2. So that information is right there in front of us. So that's helpful. We can look up the function if we care to see exactly how it's set up. Even if you can just command-click on the function if you're using an IDE like Visual Studio. So there are some downsides, though. You might have a bunch of different test cases where you're explicitly calling the same setup function. So the third approach is implicit setup. This is when we build the test fixture common to several tests in the setup method, or in the case of Mocha or Jest, the before each function. So in this case here, we're defining an address variable outside the scope of an individual test. In our before each block, we're assigning a new object to the address, starting from scratch. And then down in our test, if our test needs just the default address setup that has just one line, we can just access it just straight away. If we need 2 lines, we can just modify it because we're creating a new address, assigning it each time on each new test, and we can work with it from there. So the bulk of the data is set up in advance, and we only need to tweak the things that are going to vary in between individual tests. Of the 3 solutions to mystery guess, though, this one is the most mysterious. It's not totally clear just looking at the test exactly where the data is coming from. If your describe block is small, it might be fine, but if it's a very long describe block with a lot of tests in it, or like nested describes, deeply nested describes, it can be really hard to see where the data is set up. So if you're going to take an implicit setup approach, you really want to make sure that you're not removing the data too far from the test that's using it. So to summarize this, when you have a mystery guess situation, when that's the warning sign you see and you decide that that's a problem, you can solve it with inline setup, where you put the data right in the function, with delegated setup, where you make an explicit function call to a creation function, or implicit setup, where you use a before each block to set up the data. All right, we've got one more example using this address pattern here. We're going to start out here where we've taken the inline setup approach. And here's an example where we have a little bit more data than we did before. We've got our object here, and we've still got those fields that are needed for the test, directly accessible. But we also have these extra fields, first name, last name, country. I guess these are part of the address record. But for this test, they're not needed. They're not included in the formatted address. So this is, like, I made this a small example so it would fit on one slide, but I've seen cases where you've got an object that has other objects inside it, that has an array, that has many, many objects inside it. And you can end up in this situation if you have inline setup, where you're scrolling down through 200 lines of data setup to get to 4 lines of testing. And that is not going to make it very easy to work within your tests. So the problems in a situation like that is it can be hard to see which fields matter and which ones don't for the test. Your test can get really long, like I said. So the warning sign here is what's called irrelevant information. So the test exposes a lot of irrelevant details about the fixture that distract the test reader from what really affects the behavior of the system under test, specifically the behavior of the function we're testing right here. There's data in the test that you don't need. It slows down reading and understanding the test. You get to the point, if you're anything like me, where your eyes just glaze over and you just say, OK, some kind of object is set up, we're testing it. And it discourages me from trying to really understand the test thoroughly. If the test breaks, like, what can I do to get it passing? And then I move on. I don't really want to expend the mental energy to wrap my head around. It's hard to keep up the motivation. So there's 2 more terms about fixtures that help clarify this situation. First, general fixture. This is when the test builds or references a larger fixture that is needed to verify the functionality in question. In our case, it's just too many fields. The first solution is to do a minimal fixture. This is where we use the smallest and simplest fixture possible for each test. And in our case here, doing so is really easy. We just remove those fields that I added in that have no purpose to be in there, and we take them out, and we're good to go. We're back to our previous situation where we only have the necessary fields for this test. Very easy with an object literal setup like this. But what if you still need that data for the code to run? There could be a few different reasons for that. Maybe you're doing type verification using TypeScript or Flow, and so the type system needs those fields to be there, or needs an object of a certain instance of a class, whether or not this individual test needs those fields to be there. Maybe you are instantiating a class, and there's constructor arguments. It's going to fail unless you pass in all the necessary things. Or maybe you have a tree of functions calling other functions. You're testing through the public interface, but there are other things that are going to run. They're going to blow up if fields are missing, even though the individual validation, the formatting in question here, doesn't need those other fields. So in any of these cases, just stripping out the unnecessary fields is not going to work. In this case, you can use another solution called parameterized creation method. So this is when we set up the test fixture by calling methods that hide the mechanics of building ready-to-use objects behind intent-revealing names. We want to give the function a good name. A parameterized creation method allows the test to pass in some attributes to be used in creation of the object. In such a case, we should pass only the attributes that are expected to affect the test outcome. So we want to minimize what we're passing in. Let's look at an example of a parameterized creation method. So here, we have a default address we're setting up. We're not intending to change it. So this is just like the default fields for everything we might need for an address. We set them up. And then we have a create address function that we can call. And we can pass in overrides. We can actually not pass it in. We just get a default of an empty object in that case. But if we pass in overrides, here's what's going to happen. We get a new object returned to us. We're going to use object spread to just get all the default address fields. And then any overrides that are passed in will be applied. And because of the way object spread works, the overrides are going to win. They're going to overwrite any fields that are built in. So we can create a new address with the defaults and any overrides or no overrides that we want. We can use it here in a test, calling create address at the top. And notice here, though, although these are actually, I literally copied and pasted all these properties from the previous slide. So these are all the same values. So why would I pass these in? I'm going to get the same address out of here that I would if I passed no arguments at all. But think about what Gerard had said about this. Like, we want to pass in only the values that are needed to understand the behavior and the outcome of the test. So although the test would pass if I left these out, Including them lets the user know, okay, these are the relevant fields for understanding this test. I'm getting an address, and it has these specific values for these specific fields. There's a chance of it breaking as well if something in the shared, the setup method changed and one of these fields was not included anymore. So there's a little bit of safety as well. But it's mainly about communication, making it obvious to the user that these properties and only these properties are what matter for this test, even if we need the setup method to create other ones. So that, if we didn't include those, we'd be in a mystery guess situation all over again. So we want to avoid that. If you find yourself using these parameterized creation methods, functions, over and over again, you can use a library that's going to help you to kind of remove the duplication and do it in a bit more of a declarative way. So test data creation libraries. The one that I like to use is called Test Data Bot. It's by Jack Franklin, a great JavaScript tester and React tester. He creates great resources. And he's created this library called Test Data Bot that's going to kind of do what I just showed in parameterized creation libraries with a little bit extra. So you just import it, you build something, you use a builder, and you just give it a name. We're going to call it address. And then you pass in the fields. You can have hard-coded fields that are just going to have a default value every time you call it. You can also have sequences. So sequence is a function provided by the library. And you say, OK, the first time that I create an address, I want suite 1. The second time, suite 2. Third time, suite 3. You're going to need these for those unique email addresses that we all always need for all of our systems. So this kind of abstracts that away. You just kind of declare, here's what the value should be wherever we are in the sequence. And we can add a few more hard-coded fields. Then when we're using it, we can just call that address builder we created, and it's a similar API. We just pass in the fields we want to override, and those will be set on the object. So this can be really useful. If you really embrace this pattern, you find a lot of value from it, and you don't want to have to write a parameterized creation method from scratch every time. So to summarize, when we have irrelevant information in our test that's cluttering it up, we can solve it with a minimal fixture if we can just take out the data we don't need. We can solve it with a parameterized creation method if we need other data and other logic, but we don't need to see it in the test to keep it more simple. Or we can even use a test data creation library if we find ourselves doing that a lot. All right, example number 4. For this pattern, we're going to switch to a different example. We're going to total up an order in an e-commerce system like Shopify or something. I'm sure this is how they do it, this one little function. We read in some data from an order file again. This is kind of a pattern. And then we want to test that it calculates the correct total values when there are no line items. So we get orders 0 to get all the other setup data that's needed for an order, but then we just override the lines value for the line items with an empty array. We go and we call total order, and I guess there's a subtotal, tax, and total field in the outputs. We just make sure they're all 0, so we just start off at nice and 0. Then we got another test case. We're going to calculate the correct total order values when there is lines, so we get orders at index 0. We call total order, and then I guess, yeah, the subtotal, I guess, is $7, and then tax and total on top of that. Anybody happen to notice the problem we're going to get into in this situation running these two tests in order? So the problem is, because of how JavaScript modules work, this orders at index 0 is not recreated every time we run a test. And so we've modified order at index 0 in our previous test. So if this one runs second, order lines is still an empty array. And so we're going to get 0. This test is going to fail if we run the whole suite together because the total is going to be 0. And I've confirmed this just to make sure I'm not misunderstanding something. In Jest and Mocha, whatever test framework you're using, this well, maybe some other ones might do some magic. But this is the kind of the default behavior of JavaScript modules, so this is what's going to happen. So this is called interacting tests. It's not a good interaction. It's kind of a painful interaction, as this image shows. Interacting tests is when tests depend on one another in some way. For example, a test, maybe it can be run as part of a suite, but can't be run by itself. Something that an earlier test sets up, a later test relies on. In our case, we actually see the opposite. These tests can be run by themselves, but they can't be run as part of a suite. So this creates a really high test maintenance cost. I don't know if this has ever happened to any of y'all, but when this happens, it can be infuriating. You run the whole test suite, and something fails, but then you narrow it down to what failed, and now it's passing. So do I have to run the whole thing, or do I have to run half of my test suite to get the error to be reproduced? Like, it is so frustrating, especially if it's a test that runs kind of slow. So shared fixture has bit us again. Previously, with mystery guess, a shared fixture caused a problem because it was distant in file system space from the test. With interacting tests, the shared fixture is causing a problem because it can be mutated, and the data is now changed and affecting another test. So I really, again, recommend trying to avoid shared fixtures if at all possible. It's tempting when you have really complex objects, but you can use creation methods to kind of create those for you. Take a little effort to avoid the situation where tests can step on each other. The solution is to do a fresh fixture. We defined it before, but I like this picture. It made me feel very energized. But we'll give that definition again. Each test constructs its own brand new test fixture for its own private use. If it's brand new, it doesn't matter if you mutate it, because it's going to be safe. We can use any of those fresh fixture approaches we looked at earlier, but in this case, the simplest one would actually just be to clone the data. We can just take in orders at line 0 and then do a deep clone of it so we have a totally unique copy. If we mutate it, it's not going to touch anything else. We could actually go over in the case where we don't need to modify it and still clone it. You don't need to, because right now we're not modifying this data. But if you're going to take this cloning approach, I think it's safer to go ahead and apply it across the board. That way, if somebody else messes up a test, or if I mess up another test, this test is not going to break. This test is now safe. It can actually even be safer to just decide, I'm going to go through parameterized creation methods all the time. That way, you don't have the option to directly access the data. You're always going through a function, and you can write that function to always return newly instantiated data that's going to be standalone. So when we have the warning sign of interacting tests, some kind of fresh fixture approach is going to be a great solution. All right, we have our final pattern here. So this time we're actually going to look in the implementation of the total order function. We're peeling behind the scenes of Shopify now, not really, to see how they do it. We are using decimals for cents here, so this is definitely not how they do it. This is a terrible idea, but this is an example. So in this method here, in total order, the way I'm doing it, we go through the lines. I guess a line item has a price per item and a quantity. Makes sense. We total them up to get the total for each line. Then we do reduce to add them all the lines up. We multiply by a % to get the tax, and we add it together to get the total, and then we just return an object that has all those fields. It's pretty straightforward. So now let's look at the way we're going to test it in this case. So we're doing inline setup here, where we're setting up an order. We're trying that instead. We've got some lines, and we go in here. So once we've got our data set up, we go in and, OK, well, we go through the lines, and we map over them to get the line totals, and then we reduce it to add it up. Well, this is just the same as the production code we just saw. And maybe you, or maybe some of you you've worked with, have seen a test like this and said, why am I writing a test that's literally just copy and pasting the production code? How is this benefiting us? So this can be a big objection to testing if folks see a lot of tests like this and don't see the value. I agree that it's not adding a lot of value. If the logic is wrong in one place, it's going to be wrong in both. And so at that point, are you really testing anything? Also, this doesn't let you see the intended result in a glance. Maybe it's not obvious like what calculation is being performed. Maybe I don't know how tax calculations work. And so you can't see the outcome looking at the test. You'd have to put in log statements or something else. So the test is now obscure again. Production logic in tests is the name of this warning sign. And so here's how Gerard describes it. If we use a calculated value based on the inputs, we find ourselves replicating the expected production logic inside our test to calculate the expected values for assertions. So what can we do about this? How can we improve it? Well, the solution is interesting sounding. It's hard-coded test data. It doesn't necessarily sound the greatest, but I think it really helps us in this case. So we can start out choosing simpler values. In this case, we've set up some numbers that even I can do a little bit of math on stage in real time to figure them out. We have a line that has 2 items at price $2 each, and 1 item that has a price of $3 each. So even I can see, OK, $7 for a subtotal. That makes sense there. The 1.05 I had to do a calculator for because I can't figure that out. But at least the 7, we can see the connection there of how these things are working. There's just one concern about the hard-coded test data solution, is that Gerard actually calls it a code smell. He actually lists it as a problem rather than a solution, and I'm up here suggesting it as a solution. So the reason he calls it a smell is because it obscures the cause and effect relationship. Maybe for this calculation, or maybe for a more complex one, I'm not sure why a 7 comes out the other end. Like, I don't get it, I don't follow it. And if there's some logic that shows how the inputs get turned into the outputs, that can show that relationship. But on the flip side, we're not seeing the resulting values. So this is a case where I'd say, you should think through what's more valuable for you. Is your test better if you see the cause and effect relationship, or if you see the resulting values? You need to decide what helps you the best. But if you have a production logic in tests, and that's a warning sign that you decide is a real problem for you, hard-coded test data can help solve it. So let's review those patterns, partially because one of the reasons I did this talk is I couldn't keep all these in my head at once, and so I needed to spend months preparing. So I'll put this up here so y'all can take a picture if you want. And I'm going to post the slides as well, because this is very reference-heavy information. So when we had a flexible test situation with loops and conditionals that were hard to understand, we split them into simple tests. When we had a test that relied on mysterious data from elsewhere, we moved that data to set it up inline or other similar approaches. When we had a test that contained irrelevant information, we switched the fixture to be minimal so it was really focused. When we had interacting tests that were stepping on each other, we gave them a fresh fixture so they were independent and could be run on their own or together. And when we had production logic in the test, we switched to hard-coded test data so that we could see what the output was going to be. I'll leave that for a second. If anyone does want to take a picture, again, I'll tweet it out so y'all can download it as well. So what are the takeaways that I'd recommend coming out of this? First one is, you should read the book. It's a really good book. It's a really thick book, so you don't need to read it through cover to cover at first. But take a pass. Look through the introductory chapters that introduce these things. It has tons more information about all these patterns, how they interact, and the trade-offs. It has a ton more other patterns as well, of problems and solutions. You can pick it up on Informit is a site I love to get ebooks on, or you can get it on Amazon. So really recommend checking out the book if you want to go deeper. Another takeaway is let's talk about test patterns as a community. And let's actually use the shared language so that we're not starting from scratch in each conversation, describing a problem that we're seeing and why we think it's a problem, but we can say, oh, we have interacting tests. Let's think about how we can best solve interacting tests. So I think that shared language can really help make the conversation efficient and move things forward. And I have one last deeper takeaway as well. So you're here at a testing conference, so at least some of you really believe in testing. I'm definitely one of those people. I spent the first 10 years of my career writing untested code and suffering from it. Long nights, weekends, botched production deployments, causing problems. It was just painful for me, for the company, for the customers. It was not good. So testing has increased the quality of my code tremendously. And no exaggeration, it's increased the quality of my life. And I want other people to benefit from testing as well. And I don't want them to have to reinvent the wheel to stumble over these problems over years to come to them. I want them to be able to benefit from people who have come before me and have figured things out. So James was talking about and gave us kind of a review of some of our rich history in automated testing. So let's connect people with that. Let's use test patterns and other ways just to have conversations, sharing books, sharing our past experiences on other platforms. And let's connect people to that rich testing history so that people can make their code better and their lives better. So if you want to talk more about this, I'd love to tweet. You'll see me tweeting a lot if you're on Twitter during the conference. I'd love to tweet about this stuff, email about this stuff. I'm actually on a project right now at work where we're going into a test suite and seeing these patterns and improving things. And so if your company would like someone from Big Nerd Ranch to come in and help you think about test patterns, how they can improve your code, work together with you, we'd love to do that as well. Thank you all so much for coming and giving me a chance to talk to you. I appreciate it.